The vision of the blink of an eye is to enable, empower, and encourage quadriplegics, paraplegics, and other categories of physically challenged persons to perform simple routines like communication, to use computers and similar devices, and to move around without our inspiration. A strong felt urge to create a system which would have far-reaching consequences in liberating, comforting, and enabling physically challenged people to live life better with utmost ease has inspired us to create
LabVIEW, a wonderful journey. Initially, all we wanted to do was implement text-to-speech and use the same logic to control a locomotory aid. We have been able to achieve more than this and have created a virtual keyboard and mouse. This has been possible due to the ease of programming experienced in the graphical programming interface provided by LabVIEW from
our mission. Vision, vocal, auditory, and locomotory impairments make up the complete list of physical disabilities. The most challenging one of these is the locomotory impairment that is mainly caused due to strokes, paralysis, accidents, etc. The mission of the blink of an eye is to tackle all the above mentioned disabilities or even combinations of them and enable such patients to carry on. An overview of our module. The blink sensor is interfaced with the computer via SPRIO 9626 development board. The computer is coupled to a GSM module via USB serial interface. The blink sensor with the visual feedback from the computer simulates a virtual keyboard and mouse. The laptop is to be mounted on a wheelchair which is fabricated with DC motors, relay H bridges.
Short blink.
Short.
A long blink.
Long.
Now a complete sequence.
Short. Long. Long. Short. Long. Short.
Second sequence.
Long. Long. Short. Short. Long. Long.
The features of blink of an eye. Predefined template selection to speech. Text to speech via text to speech according to what the user wants to say. Keyboard to enable the use of a computer. Blink-based locomotion with the least demanding physical activity. Communication via SMS. This is how the main user menu looks like. The menu consists of options such as templates, keyboard, computer usage, template selection. In this mode, a row and then the column so that a particular option. Example of auto toggling, where the row or column toggling would stop only one. A demonstration.
Hello. I like the film Avatar.
As you can see here, there are 5 slots left for the user to add his own set of favorite films, where a double blink would allow him to access the keyboard and edit, add, delete the virtual keyboard. This is a basic QWERTY keyboard where the braille addresses are assigned to each letter. A dot stands for short blink and an underscore stands for long blink. A word is spoken out only after a single short blink occurs. Now let us see how.
Boolean.
Computer interface. We will now see how the computer can be used by a crosshair is achieved through two picture controls. The first blink would stop the vertical line to achieve the crosshair mode of selection. Using a browser. Once the browser is selected through the crosshair selection mode, a double blink would enable the user to access the keyboard and type the keywords. Once the text is built, it is entered into the text area of the browser where it has to be copied through the same crosshair selection. The user can also store his blink sequences to increase his browsing speed, and then assign blinks. Emergency SMS. The user caregiver during an emergency by inputting a quadruple short blink sequence. Let us see how. H-bridge circuitry. A basic H-bridge circuitry is developed through relay boards
which can be
switched on through optocouplers by SPRIO. This would let us achieve a differential motor drive to enhance the direction control of the wheelchair fabrication. The wheelchair is fabricated by altering the wheel assembly of a readily available wheelchair and incorporating a DC motor assembly, cycle sprockets, and free wheels. The shaft power is transferred to the wheels by Now let us look into the front panel for the direction selection. A single blink would toggle between directions, and a double blink would select a direction, enabling YR module. Unlike other the module requires the most simple function, that is. Now let us look into the challenges faced and possible solutions. Is required to use speech-to-text functionality. Text is synthesized via detailed pictorial classification. Slow mouse traversal. Predefined sequences are stored to minimize mouse usage. Slow typing speed. D9 predictive text can be incorporated with the same logic. What if a person cannot stop the module by blinking again? Disability to blink during locomotion. Obstacle sensors can assure the safety of the user. The scope of the blink of an eye. The module has been developed in the Windows environment. If the same is done in the Android environment, the total fabrication cost is less than half of a commercially available motorized wheelchair without arm. The blink of an eye is fast, accurate, and offers a very wide range of solutions. The blink of an eye is safe, implementable, and designed to make the futures of quadriplegics, paraplegics, and other categories of physically challenged persons less difficult. The blink of an eye liberates passionate minds trapped in disobedient bodies to express